This production is brought to you by the University of Edinburgh.
I think the other things that are interesting, I put this in as a popular application. These UAVs, obviously you've got these sort of UAV things here. Unmanned aerial vehicles are a fantastic development in all sorts of areas. Low weight, high power batteries, one key technology. The mechanical side of it is a key technology for making these quadcopter things actually fly. The wireless communications, obviously to get decent wireless communications at a distance between these devices. Okay, that's been around a while because you've always had, model aircraft, but now you're transmitting a large amount of data over possibly 50 meters. And so that's an aspect. Now, one of the things that you can do with these UAVs, and I'll probably show the video next week, is that you can fly these around and you can sense the environment. So you can build up a map of your environment around it. And there's a lot of signal processing that goes in for that, for processing information. So I had a couple of MNG projects a few years ago where we're trying to put microphones onto a UAV, and you could fly them around and try and get a speech recognition, a sort of voice control with a UAV. So it comes flying towards you and you go stop. So if you're Amazon Prime and you're going to fly a parcel into someone's back garden and it doesn't detect a little child sitting there, someone might come out and say stop to the UAV. But the trouble with that is you've got this rotor noise, which is very loud, spinning in the background. So you've got to remove the background rotor noise and wind noise. Now, what I do think, UAVs have lots of nice possible applications. They also have lots of nasty applications. So I don't want to give anyone any ideas about what you could use, but it doesn't take too much imagination. That was a research-based UAV, and costs a couple of grand. It's from a company called Ascending Technologies, Aztec. And it cost, well, at the time, that would cost a couple of £1,000 to buy. But can carry a payload of about 2 kilograms. So the BBC will go and buy this kind of quadcopter, and they'll put a nice camera on, good decent video camera, and they'll fly it around for their news reports. People will use these for filming things that couldn't previously be filmed, even with a helicopter, because you couldn't get that close with a helicopter. These things can carry a payload of a couple of kilograms. Okay, now that's bad if someone decides to go and put an IED on it and just fly it somewhere. Okay, so I think this is why I think like in the US, are clamping down on who can fly these and where. So what you need to do is possibly you need to be able to detect where these UAVs are. So these are flying around. Now, if it was a little helicopter, not a problem, because they're probably made of metal. You can use radar. This thing is mostly made of plastic. Plastic doesn't have particularly good radar returns. So how do you detect where these are flying? Well, you might be able to sort of detect the communication signal. That could be one possibility. You might be able to use infrared sensors. That could be another possibility. But it's a tough problem. You might be able to use sound, because at least you can hear these things from a distance. So over the next 20 years, I think some of the companies like Celex and BAE Systems will be, some of their projects will be, for example, can we detect where they are? I've just got a few minutes left, so there's a picture of a radar. I'm not going to go through everything that's in handout 1. It tries to motivate lots of different possible ideas about what signal processing is, and you can go and have a look at them. Just to give you, just to summarize what the applications are: biomedical, homeland security, analyzing CCTV images. We've got some nice cool projects at the moment. You've got a CCD array and you want to track, if a person goes from one camera to the next automatically. Tracking and navigation, in the UK, fortunately there's radars everywhere, so you can track most aircraft, but obviously there are parts of the world where you don't have full coverage of tracking every object. And speech enhancement and recognition is an obvious one. And so I think what I'm going to do, I've got a couple of minutes, so I'm just going to go through this diagram, which you can half see. And it makes you sort of think, it's a very simple application. is how do you go from a signal recorded in a studio to what you listen to on your headphones? And just think about all the steps involved and think about where signal processing could come in. So the first thing is, let's someone's playing some music. So we need to record that music. Because we're in a studio, we can soundproof it, so we can reduce reverberation and noise, and we can probably get the microphones quite close to the instruments. We need to record that somehow. If you lived 40 years ago, you'll be using tape, using analog signals. Now we do analog to digital conversion. Okay, so you've got an ADC. How many bits are you going to use? How fast are you going to sample, and why? And how are you going to sample? We'll store that on a I'll put a digital audio workstation, but that will probably connect via fixed line communication, as Popular said, to the network, and it might be on a server. So Spotify, for example. So we could, for example, we go through this route here, there's other routes on the full diagram. If we use our 4G connection to download Spotify, obviously you've got the mobile wireless communication, and that will get to your phone, but then you might have a short range personal communication, so you should have a Bluetooth connection, and that can arrive at the headphones. Now 10 years ago, all the rage seemed to be we need to compress the signal, so that's why we're listening to MP3s and then 10 years ago, or compressed signals. Right? There's actually no reason nowadays to listen to compressed music. If anyone's listening to MP3s, ask yourself why. Seriously, is anyone listening to MP3s? Generally, yeah. I mean, so it's an interesting question. Why? Why? It's like the bandwidth is amazing. You've got Netflix. You can download 4K movies. The amount of data in an audio stream is infinitesimal compared to a 4K 3D movie. So why are we listening to compressed music? Right? There's no reason to. Download your high-def 24-bit 192 kilohertz tracks. So we'll discuss why they could be good things. So that's where the rage used to be 10 years ago. What's the best compression format? Well, forget that. MP4 is more interesting for compressing video. So if you sort of think about how much data, when I've got a 4K, when James Cameron comes and makes the next Avatar films and he records them at 60 frames per second, like they try to do with The Hobbit, when you come at 60 frames per second, 4K, possibly 8K in 10 years' time, 4K picture in stereo, because it's a 3D image, think about how much data is involved in that, and think about how you're going to compress it, and think about what's involved. And when you think about those topics, that's when we're beginning to get an idea of what signal processing is. Okay, so that's an introduction. On Tuesday, we're going to actually start looking at the basics of a method.
This production is copyright the University of Edinburgh.